on to a little solving equations review. Okay, so here we go. Just a couple different scenarios we're going to go through. I'll do the left side. This will be like an I do, you do type thing. Okay, so I'll do the ones on the left, and then I'll have you pause the video, try the ones on the right, and then I'll go through the ones on the right so you can see if you did them correctly. All right, so this first scenario, they gave us solving equations by combining like terms. So just like every equation, I'm going to start by, drawing that wall just so I can see, okay, what's on the right side, what's on the left side. Variables on the left side, I see like terms with these x's. So I can see that's a 2x minus 4x. 2 minus 4 is a negative 2. But then I also see these constants, a positive 5 and a negative 2. So 5 minus 2 is positive 3. So I'll put plus 3 equals negative 24. And now it's just a two-step equation, right? So get rid of the addition or the subtraction first. In this case, it's addition, so subtract 3 from both sides. And we get negative 2x equals negative 27, right? Negative 24, and then take away 3 more, you're at negative 27. And then divide both sides by negative 2. And we know a negative divided by a negative is a positive. 2 goes into 27, 13 and a half times. 13 and a half. And it is a positive 13 and a half. Okay. All right, go and pause the video. Try the right-hand side. All right, so on this right-hand side, let's see how you did. Same thing. There's just a lot more like terms to combine. Okay, I see a bunch of r's. I'll start with those. I see a positive 6, and then minus 1, and then minus 3 more. Okay, so positive 6r minus r, that's positive 5r, and then subtract 3 more r, and that's 2r. So it's 2r. But then I also see all these constants. 1 minus 5 is negative 4. Negative 4 plus 4 is 0. But then I have this plus 12. So 0 plus 12 is 12. All right, so I have 2r plus 12 equals 48. I'm going to subtract 12 from both sides. And I get 2r equals 36. 48 minus 12 is 36. And divide both sides by 2. And I get r equals 18. All right, so moving on to the next scenario they give us. Just says solving equations by distributing. Remember, anytime you see a number written outside of parentheses, you know you have to multiply that number by whatever's inside the parentheses. So that's what I'm going to do. I've got 4 times 1, and then I've got 4 times negative 3k. Well, 4 times 1 is 4. 4 times negative 3k is negative 12k. And that is all equal to 88. All right, and now it's just a two-step equation. I'm going to subtract 4 from both sides first. That will get me negative 12k equals 84. 88 minus 4 is 84. And then divide both sides by negative 12. A positive divided by a negative is a negative. So I know k equals a negative number. And then 84 divided by 12 is 7. All right, so pause the video. You try the right-hand side. All right, guys, on the right-hand side, you're going to subtract, or you're going to distribute the negative 4 from both sides. I've got negative 116 equals, so negative 4 times 4x is negative 16x. Negative 4 times a positive 5 is a negative 20. All right, and we just do the opposite from here on out, right? So I'm adding 20 to both sides first. Okay, negative 116. So to get back to negative 100, that's 16, and then 4 more. So negative 96 equals negative 16x. And then, all of a sudden my nose is running, I'm sorry. Then divide both sides by negative 16. Oops, forgot my negative sign on that side. So those cancel, and I'm left with a negative divided by negative, which is a positive 6. Hopefully you got x equals 6 for that one. The next scenario they gave us, I'm going to switch up the colors just so these don't start running into each other. It says solve equations with fractions. So for this one, I've got a fraction that I'm supposed to distribute. So I'll do that, draw my wall. 1/2 times 12n, that really means half of 12n, right? So half of 12 is 6, so I've got 6n, and then 1/2 times negative 4, that's half of negative 4, is negative 2. So that equals 6n minus 2 equals 22. Now it's just a two-step equation. Add 2 to both sides. We get 6n equals 24. And then divide both sides by 6. Those 6's cancel. 24 divided by 6 is 4. I'm left with n equals 4. Okay, I'm actually going to do this next one with you. This time, x is part of a fraction. It's the numerator. And when it's part of a fraction like that, that just means x is being divided by 6. Okay, so I'm going to subtract 4 from both sides first. I get x over 6 then is equal to negative 2. If x is being divided by 6, we know we always do the opposite to solve an equation. So I'm going to multiply both sides by 6. And when I do that, those 6's cancel, and I'm left with just x equals a negative times a positive is a negative. All right, I'm really sorry, guys. I got to blow my nose real quick. All right, see if we can't finish this video. So moving on, we have solving equations with variables on both sides. All right, if you remember this year, we showed a couple different ways to do this. For this video, I'm just going to get rid of the smallest variable. I know that's what most of you preferred. So that's what I'm going to do. But first, we have to simplify. So in this case, that means distribute. Well, luckily, I mean, this should look familiar. We just did it up here, up above. I've got to do 1/2 times 12n and 1/2 times negative 4. 1/2 of 12n is 6n, and then 1/2 of negative 4 is negative 2. Okay, so the right-hand side is already simplified. There's nothing to combine. There's nothing to distribute. I'm ready to get rid of the variables on one side. Okay, I'll get rid of the smaller one. The smaller one in this case is that negative 10n, right? Negative 10 is smaller than 6, positive 6. So I do the opposite. I add 10n to both sides. Negative 10n plus 10n, they canceled each other out. So I'm adding 10n to both sides. Add 10n. 6n plus 10n is 16n minus 2 equals 14. Now I'm ready. It's just a two-step equation. Once you get rid of the variables on one of the sides, it's just a two-step equation. So I've got add 2 to both sides. 16n equals 16. And then divide both sides by 16. I'm running out of space. 16 divided by 16 is just 1. So I get n equals 1. Okay. For the other problem, go ahead and pause the video, see what you get. All right. Well, let's see how you did. So I'm going to draw my wall. I say I have to distribute on both sides. So this is 1/4 times 12 and 1/4 times 6. So I've got 1/4 of 12, which is 3. So 3x. And then 1/4 of 6, and that would be 1.5. And then on the other side, oh look, I've got to distribute again. It's not 3 that I'm distributing. Hopefully you saw that minus sign in front of the 3. You're actually distributing the negative 3. So the 10 comes down, But then that's negative 3 times x, that's negative 3x. And negative 3 times negative 2, which gives me a positive 6. If you remember earlier this year, we had a problem like this on a quiz. A lot of people missed this because they didn't see that minus sign in front of the number that we were distributing. Okay. All right. I can still simplify the right-hand side, so let's go ahead and do that. The left-hand side will stay 3x plus 1.5. But on the right-hand side, I see that 10 plus 6. You see that? Let me use a different color here. I see this 10 and then this plus 6. Those are like terms. Neither one of those have a variable. I can combine those, and that is 16. So I've got negative 3x plus 16. Well, we've got variables on both sides. I'm going to go ahead and get rid of the smaller one. Negative 3x is smaller than positive 3x, so I'll get rid of it. To get rid of it, you add or subtract. In this case, it's already a negative, so I'm going to add 3x to both sides. And that's going to give me 6x plus 1.5 equals 16. All right, so here we're ready to, and now it's just a two-step equation, right? Here we're ready to just subtract 1.5 from both sides. And that's going to get me 6x equals 14.5. And then just divide both sides by 6. That'll get the x by itself. Actually going to do that one on the calculator. 14.5 divided by 6 equals it's a decimal number, 2.416 repeating, but that if you use your calculator, change it to a fraction, which you guys know I like fractions better. We do get x equals 2 and 5/12. Okay, or 2.416 repeating. Okay. All right. For this next one, the last one on this page, it says here, find the value of b so that x equals 2 is the solution to the equation below. So if I know that I want x equal 2, they're telling me I want x to equal 2. Put in 2 for x. Let's rewrite this. If I put a b there, now it's 2 times 2 plus 6 equals 30. If I put in that x is 2, I can simplify this equation and then see what's left for b to equal. Okay, b is being multiplied by all this, but I'm going to follow order of operations and do what's inside the parentheses first. 2 times 2 is 4, so I have b times, and then in parentheses 4 plus 6 equals 30, and then 4 plus 6 is 10. So really this is b times 10 equals 30. To get b by itself, my last step, since it's being multiplied by 10, just divide both sides by 10. If I divide both sides by 10, I get that b would have to equal 3. Okay, and there's a way we can check this. If I just put in 3 for b in the very beginning, do I get that x equals 2 when I solve it? Right? So if 3 is the number outside the parentheses. So I'll try that in a different color. 3 and then 2x plus 6 and then equals 30. Okay. If I go to solve this, I should get x equals 2 if I did it correctly. So let's see. 3 times 2x is 6x. 3 times 6 is 18. Now it's just a two-step equation. Subtract 18 from both sides. I get 6x equals 12. And divide both sides by 2, or by 6. Whoops, said the answer. X does equal 2. So I did it correctly. If x equals 2 is the solution, which I just worked it out and it worked, then b has to equal 3. So that's my answer. B equals 3. All right, I'm sorry. Go ahead and turn to the next page. I got to blow my nose one more time. All right, hopefully now we can get through this. So on the next page, we have some special cases, and this is similar to how we reviewed special cases earlier. So for one solution, you know, it's going to work. You're going to get an answer for x. Like for instance, this one, draw my wall, combine these like terms here. I see a 5x minus 4x. I see 2x plus 2. So 2x plus 2 stays the same. But I can combine these like terms on the right. 5 minus 4 is 1, so just x plus 4. I don't have to write the 1 there. Get rid of the smaller one. That would be subtract x from both sides. And we get x plus 2 equals 4, because those x's canceled, and just subtract 2 from both sides. I get a number, right? I get x equals 2. But what is it about the setup of the equation that let me know I was going to? Okay, if you remember when we were doing systems of equations, we looked at the slopes of the numbers in front of x, in other words. Okay, they had to be different for us to get one solution. Well, look what happened here. When I simplified, I'm going to use a different color. When I simplified that equation, look at the numbers in front of x. They're different, right? So I'm going to put different values for x. That's how you know it's not different values. Sorry, this is why we use pencil. Different coefficients, those are the numbers in front of x, for x. Those numbers were different. On the right-hand side, it was 1 when we simplified that, and on the left-hand side, it was 2, okay? For the no solutions, again, it's not simplified, so let's simplify it first. So I've got 3x right here, and I've got negative 2x here. Well, 3 minus 2 is 1. I don't have to write the 1. I can just write x. Bring down my little plus 1. Don't forget the wall. Equals x plus 5. Well, what's going to happen here? Get rid of the smaller x. They're the same size. So it doesn't matter which one you do. I mean, if you subtract x from both sides, you're left with 1 equals 5. No, it doesn't. So this is not true. Not true. So we're left with a false statement. And when you're left with a false statement, that's why the answer is no solution. What that's saying is there is no value for x that you could put in for this equation that would make it true, right? Well, what is it about the equation that showed us that it was going to be no solution? Look at our x terms. When I simplified it, let me again use a different color. When I simplified it here, I had x plus 1 equals x plus 5. So the x terms were the same, but the constants were different, right? The x terms were the same, but constants, not were, just are different. And that's how you can tell by looking at an equation, just a normal old equation, not a linear equation, just like this, and just a regular equation. That's how you can tell if it's going to be no solution. Okay? And then finally, infinitely many solutions, where this is different. I'm not going to be left with a statement that's not true. I'm going to be left with a statement that is always true. It doesn't matter what number you put in for x, and I'll show you what that looks like. Okay, the first thing I got to do is simplify. I see on the left-hand side, I have this plus 2, and then this minus 4. Well, 2 minus 4 is negative 2, so I have 2x minus 2. On the right-hand side, I've got to distribute. 2 times x is 2x. 2 times negative 1 is negative 2. Right away, what do you see? The equations are exactly the same on both sides, right? So I've got to get rid of the smallest x term. They're the same. So whatever, just subtract 2x. Oh, look at that. They both cancel out. I'm left with negative 2 equals negative 2, which that is true. And what that's telling you is it doesn't matter what number you put in for x, they're going to cancel each other out anyways, and you're going to be left with a true statement. So infinitely many solutions, okay? When we simplified this, what did we notice? I'm going to circle that in a different color here. What did we notice? We noticed everything was the same. The x terms were the same, and the constants were the same. So x terms the same, x terms were the same, but the constants were also the same. Constants the same. So we don't care. For one solution, I want to point this out. For one solution, we don't care what the constants are. Just the x terms had to be different. The coefficients had to be different for x. For no solution, the x terms were the same, but the constants were different. And for infinitely many solutions, everything's the same. Once you simplify, okay? And that's what this question down here is really getting at. What can I do so that it has no solution? Well, what does no solution mean? We just wrote it down. That means x terms the same, so x terms have to be the same, but constants have to be different. So x terms the same, constants have to be different. Have to be different, okay? So let's simplify this. All right, let's simplify this the best that we can. I've got 2/3 and then 6x minus 12 in parentheses, and then on the other side 1/2, and that's being multiplied by b plus 16 in parentheses. So let's simplify this. I've got this left-hand side, which doesn't have the b, right? They're asking me what's the value of b to make it no solution, so that it meets this criteria right there, okay? So on the left-hand side, that's just all stuff I know. Let's simplify it. 2/3 of 6 is 4. So we've got 4x. And then 2/3 of 12, negative 12, is negative 8. So what needs to be on the same side? When I distribute the 1/2, what has to be on the same side or on the right side? Well, for this to be no solution, my x terms have to be the same, but my coefficients need to be different. Okay, well, they will be different. I mean, I know the 1/2 times 16 is positive 8. So they are different. What does b have to be? Half of b. So b, the only thing that b cannot be is 8. Because what's half of, sorry, it cannot be 8x. Because what's half of 8x? Oh, no, sorry. I was thinking about that wrong. It has to be 8x because the x terms have to be the same. Let me highlight that over here. The x terms have to be the same. So I have to get 4x on this side. And the only way I get 4x is if I do 1/2 times 8x, right? So this has to be 8x and then 1/2. Whoops, let's do the 1/2 arrow there. The 1/2 times 16, of course, is positive 8. Oops, I'm making all kinds of mistakes here. This has to be 4x. So what does b have to be? 1/2 of something equals 4. That's 8, and then the x is there. So b has to equal 8x. Whew. Moving on. For this one, we've got the equation 5, and then in parentheses 3x plus 7, and then outside of parentheses minus 1, equals 3, and then 5x plus k in parentheses, and then plus 4 at the end. Has infinitely many solutions. So let's write down what that means, right? X the same, I'm going to abbreviate x the same, and constants the same. Constant the same. So basically everything has to be exactly the same on both sides for it to be infinitely many solutions. So let's simplify this, right? Distribute first. I get 5 times 3x is 15x. 5 times 7 is 35. But then I have the minus 1 on the end. Don't forget that. Okay. Well, 15x, I've got plus 35 minus 1. 35 minus 1 is 34. So on the left-hand side, which has everything that I need, I get 15x plus 34. For this to be infinitely many solutions, that has to be exactly the same. Okay? So when I distribute this, this better be 15x. Well, it is. 3 times 5x is 15x. But what's 3 times k? Well, 3 times k is 3k. But I also have the plus 4. Okay? The 15x's match up. That makes that true. The x's have to be the same. All good. What do I have to do to figure out what k is? Well, remember, the constants have to be the same too. So this and this have to be the same. 3k plus 4 has to equal the same amount as 34. So that's another equation we're going to set up. 3k plus 4 equals 34. It has to, for it to be infinitely many solutions. So I'm going to solve this. It's just a little two-step equation. Subtract 4 from both sides. That gives me 3k equals 30. And then I'm going to divide both sides by 3. 30 divided by 3 is 10. So it has to be 10. Okay? K has to be 10. K has to equal 10 in order for this to be infinitely many solutions, because that's what will get it to equal 34. Right? Plug that in. Plug that into right here. And just check. 3 times 10 is 30. Plus 4 is 34. 34 is on the other side. We're all good. All right. Last but not least. So I've got this inequality. It says create an inequality to show the solutions to the inequality shown below. Remember, when we solve an equation, our answer is an equation. I'm pointing to this one right here. That's an equation. When I solve for k and I said k equals 10, that's an equation. When we solve an inequality, we just show our answer as an inequality. So that's all it means. When it says create an inequality to show the solutions, that's how you show your solution. That's how you show your answer, is with an inequality sign instead of an equal sign. So here, we've got 4 times 4g plus 3 in parentheses, right? So I'm going to distribute. I can see that already. On the right-hand side, I have 14g plus 5.5. Let's solve it. So there was one thing special. I was on eraser. Whoops. Remember, the one thing special with inequalities is that when you divide both sides by a negative or multiply both sides by a negative, you flip the inequality symbol. But we solve them the same way that we solve equations. Okay, simplify first. 4 times 4g is 16g. 4 times 3 is 12. And then on the right-hand side, it's already simplified. Okay. I'll go ahead and get rid of the smaller g. Get this little g out of here. I'm going to subtract 14g from both sides. I already messed up. Did you catch it? I put an equal sign instead of my inequality. My inequality symbol is that greater than or equal to. Okay. So I'm going to subtract 14g from both sides. That cancels on the right-hand side. 16 minus 14 is 2. I got 2g plus 12 is greater than or equal to 5.5. Okay. Next, I'm going to subtract 12 from both sides. That'll give me 2g is greater than or equal to, what is that, 5.5, 5.5 minus 12, negative 6.5. And my last step is divide both sides by 2. When I divide by 2, I'm not dividing by a negative. I divided by a positive 2. So my inequality symbol will not change. It's still going to be a greater than or equal to symbol. G has to be greater than or equal to, and then negative 6.5 divided by 2 is negative 3.25, or negative 3.25. Okay? That is what they mean when they say create an inequality to show the solutions. I mean, G just has to be bigger than negative 3.25 or equal to negative 3.25 to make that true. All right, guys, that does it for our solving equations review. Make sure you ask your teacher if you have any questions.